Yeah, so question 13 says if n and m are integers and n squared plus m squared is even, which of the following is impossible? Okay, so the idea for this is if you have n squared plus m squared, this has to be even. So this is even. Then that tells us that, like, how do we get an even number? Well, to get an even number, we can either have an odd number plus an odd number, or we can have an even number plus an even number. Those are the only two ways to to get an even result. So like, let's take a look at this first case, right? If you have two odd numbers, if you have two odd numbers, that means n squared is odd and m squared is also odd. So if n squared is odd, that tells us n is odd, right? Because n clearly can't be even, because even number squared is going to be even, so that's clearly not possible. And if m squared is odd, that also tells us m is odd, right? So if n is odd and m is odd, then this will satisfy the conditions. So that already eliminates choice B that says n and m are odd. So let's see. Let's write down the answer choices are A, B, C, D, E. So clearly it can't be choice B, so you can cross that out. Now if n is odd and m is odd, then n plus m is going to be even, right? Because odd plus odd is even. So we can also eliminate choice C. Yeah, so now we can look at the second case here when they're both even. That means n squared is even and m squared is even. So that tells us if n squared is even, that tells us that n is even. And if m squared is even, that tells us m is also even. So if n is even and m is even, that clearly eliminates choice A when that says n and m are even. Now, if you take n plus m in this case, it'll still be even. So notice that, like, no matter like what case you're looking at, n plus m is always going to be even. It can never be odd. And that tells us that, like, choice D, n plus m is odd, is also impossible. So we can cross out choice E. So that tells us that choice D would be our answer, that n plus m cannot be odd.